Yeah, Viola, you can start.
Okay, great. Thank you, Lin. Hi, everyone. So today we're going to be covering a little bit more of the Tact programming that we started 2 days ago, around that time. So let us do a quick recap. I hope everybody can see my screen. And last time we were trying to design a crowdfunding campaign in Tact. And we built a really simple version of it, which won't actually scale. So let's do a quick recap of what we have done previously. We haven't tried to build the contract, and I'm sure there are some maybe syntactic errors and stuff like that. So what we have now is that we have a crowdfunding campaign which stores its goal and deadline. The goal is the amount of money we would like to get at the end, and also we store the map of backers. So this is the part which actually does not scale. Yeah, so here we can see owner 2. This is our attempt to actually try to deal with this issue when, for instance, the owner just loses their private key. And so like these, all these funds can be just frozen. So let me actually delete over here. So that was just like one of the suggestions. So another suggestion that we can provide here, I will show it actually. I won't be like writing this from scratch. I will just show you a ready version and how to test it. But let's go a couple of steps back. Actually, just one step back, and there is an owner, there is a goal, there is a deadline, there is the info. We actually save who donated how much, right? Because we want to be able to provide refunds for people. So this is sender here is the deployer in the init constructor, and we just save the goal and the deadline, and this map, it is empty by default. And we can receive several, like 3 types of messages. We can receive the donate message. So if someone bumps donate against my contract, then I check that the campaign is not over yet, right? So now is less than deadline. And we check also that the sender did not donate previously. This is just how we design this stuff. So nothing actually prevents us from implementing a contract which allows you to donate several times. That just depends on your basically use case and business logic, right? So this is where we check that if we have already an entry in the map with this sender, then we say something like backer already donated and bailout, we throw an exception. Otherwise, we store the donation in the map. Or when people are trying to get refund, we need to check that the campaign was not successful. So it is after deadline and the goal has not been met. And then we check that the address, the person, the wallet that tries to get refunded, they actually previously donated, right? So here we're checking that this donation is not null. And then we store this info that, okay, they will get refund, and we just send the donation minus small fee for processing and storage, right? And then the same goes for claim funds. Only the owner can claim funds. They can only claim funds after deadline, and only in the case when the campaign was successful. And we send all the remaining balance of the contract to the owner and destroy the contract because it's like one-time campaign. So that is pretty much it. It's pretty simple logic, right? It doesn't scale, but we also stopped last time this issue. What happens if the owner loses their private key and they are not able to claim funds? So this does not seem fair to the rest of the people. Like, it can be millions. In this, for this contract, it cannot actually be millions of backers, but in real life, it could be millions of backers who are willing to donate. And it's not fair to them to keep all these funds forever frozen, right? So to overcome this issue, we can do something like this. So a straightforward solution would be, for instance, to introduce one more deadline. So there is a campaign deadline like before, and there is a claiming deadline. So I already added some stuff here in this new contract, which also does not scale because it has the same backers map, right? So the only difference here is that we introduce a new deadline, which is supposed to be greater than the campaign deadline. That means that the owner of the contract has like not an infinite range to claim the funds, but some window, right? And so if they fail to withdraw the funds, if they fail to claim the funds in this within the bounds of this window, then we allow every backer to get their funds back. So this is a straightforward change in the source code here. So I'm adding a new deadline. I'm also checking that this is when the owner can actually claim the funds, that it is before the second deadline, right? The claiming deadline, so to speak. And then for refunds, we are now checking that, okay, it needs to be after the campaign deadline. And if it is greater than the claiming deadline, we get refunded unconditionally. Other than that, so if we are after the second deadline, then we can always get that deadline. Doesn't matter that campaign was successful or not. So, and in this else branch, we are checking, okay, if we are within this window when the owner can withdraw funds, and we need to check that, okay, the campaign is not successful, and so the owner cannot withdraw, but we can, right? And so the rest of this is totally the same. And maybe compared to the previous version, I added some so-called getters. Getters are functions that allow you to read contracts data, for instance, but it is only off-chain, right? So another contract cannot call these contracts getter, because contracts can only communicate using messages like this, using the send construction. And usually people define getters, for instance, for the testing purposes. And so I also defined it when I was working on the tests. So let me show you next how you can test this locally, because this is the kind of the best way to test your contract. And to do that, the Blueprint framework, it creates this crowdfunding spec.ts file. It is actually, it was already written here by myself, right? And I will just walk you through the source code and show you how it's technically done, and show the test cases that I'm checking. So this the template for this set of tests was provided by Blueprint, the build and test and deploy tool for the Ton blockchain. And so I also only needed to add these unit tests, like each should do something. And so the rest of this was written automatically, except for instance, this stuff, which is some basically constants that I needed to deploy my contracts and some helper functions to make the test code less verbose. Okay, so we have like an emulator which you can interact with using TypeScript, and we have blockchain, we have so-called treasury contracts, which is basically like wallets, right? So there's a deployer, which is, in our case, this will be the contract owner. And this is actually has great discoverability because the sandbox contract, so that's the blockchain emulator, in this case is called Sandbox, so that's why it's called Sandbox contract. And as you can see, you see this crowdfunding type, which comes from the automatically generated wrappers. If you go to this, by the way, you can create a new project. I probably missed this part by saying something like npm create ton at latest. Sorry, there's a window that hides. Yeah, latest. Like this, and then you will go through a series of questions. You will pick what kind of contract you want to, contract template you want to create automatically for you, and so on and so forth. So you can pick a language, either Fancy or Tact here. And these wrappers are automatically generated for you when you do npx blueprint build. You would see something like this output that we call the Tact compiler, which produces the Fancy result, which then we invoke the Fancy compiler, which produces basically fifth. And here it's actually the next version that we're gonna be building now. So, and we generate this representation of the contract in this BOC format, which stands for bag of cells. A cell is a basic building block on the Ton blockchain. It's like a piece of data, 1023 bits of data, and up to that, actually, up to 1023 bits, and also up to 4 references to other cells. So this allows you to build everything as like quadruple trees. And so here we're, okay, let me switch back to the tests. We need to deploy our contract, our crowdfunding contract. We need to develop, we need to define this campaign start, campaign deadline, claiming deadline, funding goal, all these parameters. This is Unix epochs, so this is in seconds. Hence, you can see this division by 1,000 because in JavaScript it is actually milliseconds, not seconds. So here, for instance, you can see the funding goal for us is just 1,000 tons. And here, in this case, I'm a little bit sloppy with regard to how to check balance. We are just checking balance not for exact equality, because there will be some gas fees, and the amount of tons we send to our contract won't be exactly like, if I send 100 tons, it will actually get a little bit less than that. But we're not building some production ready software here, so I'm being sloppy here. Sorry for that, but it's for the sake of simplicity, basically. Right. So here, before each, this is just tests, just base tests. You can probably read online about this. It's pretty well documented. Framework, I'm sure many of you have used this framework. And so we deploy before testing, we deploy the contracts. So for instance, you can see here crowdfunding. We send a message with the type deploy, and this actually comes from this. The reason we have this trait deployable, right, and which introduces this deploy receiver. So we send this deploy message. And after that, we check that the deploy result has actually this transaction. So this should deploy. We don't need to do anything, yeah, because it is done before each test. And then we can proceed checking our happy path or sometimes unhappy path along the way. So for instance, here, this is, I'm creating here 3 backers using the blockchain.treasury method. I'm checking what happens before the campaign deadline. So this is how you can set your blockchain time. So blockchain.now equals campaign start +1, for instance. And then you just send a message, for instance, this backer1.getSender. So basically you need sender, a parameter of type sender here. We say we are donating 101 Toncoin, and these values are supposed to be in nano Toncoins. So that's why I'm using this to nano wrapper. And then I check, okay, it should have this transaction with this, the address from backer1, and it needs to go to the crowdfunding contract. And I'm checking that the balance is approximately 100 Toncoins, give or take 1 nanotoncoin. Of course, in production systems, this is non-negligible, but here we just overlook this. So I'm sending several donations. So for instance, here I'm sending a second donation of 300 nanotoncoins, and then I'm trying to claim the funds. So for instance, here the deployer, who is the owner of the contract, tries to send this message called claim funds. And we just provide some small amount of Toncoins to pay for the transaction itself. And so for instance, here in this send method type signature, you can see that the messages can be either claim funds or donation or refund or deploy. And this is, well, in this case, it should be refund in as a string, not as a name like this, not as a constructor identifier, because this is basically generated from a different version of this contract, but it would be auto-generated for you, and you will know what kind of messages you can actually send. And if you don't see, if you added one more receiver and you don't see it here, you probably need to do npx blueprint build. And when I'm testing stuff, I usually do it like this. So it is build and always test after that, because it's a source of many errors when people change the source code but then forget to build, because this build command not only produces this basically TVM instructions, but it also produces TypeScript wrappers. So yeah, I'm trying to withdraw funds, and then I'm checking that in reality, the balance has not changed with regard to the previous value. So it's still 300, around 300 Toncoins. So that means this transaction was not successful. And then we add one more donation, 700. So this makes it's a bit more than 1,000 Toncoins, which makes the campaign basically successful. And now I'm checking that we are in the middle of these two deadlines, which means the owner can claim funds in this case, but backers cannot, right? So here we check that, for instance, backer number 3 tries to claim funds. Well, actually, yeah, backers are not authorized to do that. And I might as well maybe add one more test case. For instance, I can try to say that backers cannot get refunds. Cannot get refunds. So how do we do this? We say get refund here. Yeah, I need to restore the previous version, otherwise I will be seeing this type error. So let me probably go ahead and do this. This is the non-scalable version. Let me just call it like this and say npx blueprint build. Let's see if it builds. Yeah, it is successfully built. And let me go to my tests. Right, so yeah, this is the spec. And now you can see that the type error went away because we rebuild everything with regard to the contract we're supposed to be testing. Right, okay, we can see that this should be the same thing. Backers cannot get refunds because the campaign is successful. And we need to check that the owner, who is our deployer, they can claim funds. And so here the contracts balance is supposed to be around approximately 0. And let's actually run tests. I just added a new one. So let's see. I didn't save, right? Yeah, I was supposed to save the source code. So let me check it. It passes, and let me do it again, just in case. Yeah, it works. Right, cool. So, right. So next test, it's all kind of the same, right? You can create backers. I could probably move it to wider variable scope, so I don't have to create these variables in each and every test. So here, for instance, I'm defining 2 backers and 1 non-backer. So this one is not supposed to be donating. So again, I'm doing 2 donations, and here I'm checking that, again, owner cannot claim funds because the campaign is not successful. And we need to make sure, for instance, that backer 1 can get refunds. So let me check. Yeah, this is after the campaign deadline. So we are checking that backer can get a refund. And so how do we check this? We record the current balance, then we ask for a refund, and then we first of all we check the contracts balance, which is supposed to be 200 in this case because it was 300, and the first backer donated 100 coins. And we also need to check that the contract refunded the right person. So this is why I'm doing this kind of stuff, right? So I check the balance of backer 1, and I see that, okay, yeah, they got something like what they donated, right, back. We check that backer 1 cannot get a refund twice here. So after this one, we try to do the same thing. And here I'm trying to check the balance, and this is a helper that I wrote for these tests. So for instance, I'm asking to get contract with this address, crowdfunding.address, and I'm asking for its balance, right? And then I'm checking that it is within some range. We're checking as well that non-backer cannot get a refund by checking that the contract balance is the same as before. And we at last we're checking that, okay, yeah, we can, all the backers can get a refund. So there is like no fund leakage. And here, for instance, it's again, it's successful campaign, a third test. It's a successful campaign, and there are again 3 backers that donate 100, 200, 700, which makes it greater than one, which makes it meet the campaign goal. And then we wait until after this window for the owner to actually get the refund, to claim funds. And so after this window, we are checking that the owner cannot claim funds. So the contract balance stays the same. It is around 1,000. And then we check that all the rest of the people can get a refund. And in this case, I'm not checking again that the right person got the right amount of money. So, but you can expand this, for instance, if you want to do that. All right, so this is it. This is how you test the contract. You just use the sandbox library, and you use auto-generated wrappers and some helper functions from the Ton core libraries. So here you can see the imports. It's Ton sandbox, Ton core. This is what was auto-generated by the Tact compiler, and here some details. All right, so let's switch to the final part of our workshop. Last time I said, and today again, I said that this version of crowdfunding contract is not scalable. So let us rewrite it into a scalable version. To do that, I will be, let me actually create a copy of this file, and I will be trying to modify it. Okay, so let's make it scalable. So first of all, we should get rid of the stuff that does not scale. So the backers map has to go. That's it. Well, not that easy, right? So how do we still need that info, right? Because we need to be able to refund people. But instead of keeping a map, and again, I can remind you that why this does not scale. So there are blockchain limits on gas for one transaction, and blockchain limits on the amount of storage one contract can have. So for instance, it can store maybe 100 or several hundred backers in one map. And after that, we will just overflow the contract storage. And also when you add more backers to the map, it makes it less gas efficient, and it requires more and more gas to actually expand the map. So at some point, even if we had, if we didn't have this like kilobytes, tens of kilobytes restriction for contract storage, we still would get out of gas errors when we try to grow these maps to like some huge sizes. So right, instead of this backers map, we will be using the blockchain as our map. So the Ton blockchain is going to be our distributed map, because contracts on Ton blockchain can deploy new contracts at predictable addresses, and that will be pretty important for us for the whole workflow. Okay, so I'm removing this part, and to let me add, we will be needing one more contract. So for instance, how can we do this? How can we design the system that allows us to, for each backer, to deploy a new contract that would have the info, like how much they donated? How can we do this? So for instance, we could go for an architecture like Jetons or fungible tokens, or something like Ethereum analog would be ERC20 contracts. In our case, we could probably deploy a new contract and put there the ton coins, kind of forward the ton coins there from our crowdfunding contract. And it would have a custom logic, some custom logic. So the user won't be owning those funds. There will be a restriction that they can get refund only if the campaign is unsuccessful or this deadline for claiming funds is missed by the contract owner. But this essentially creates this map of, so you would have for each backer, you would have a contract, a custom contract with these ton coins that they donated, right? But this makes the owner, it actually makes it really hard for the owner to withdraw those funds. They cannot go here and say, all right, I just want you to send all the remaining balance of this, let's call it master contract, right? It's not possible anymore if we kind of distribute money all over the blockchain. It is possible to do this off-chain, so you could have some kind of script that would parse blockchain transactions and understand where all these donations went, and then the owner would have some kind of logic to withdraw funds from each and every contract, which is not really gas efficient. For instance, you would still have to like traverse millions, potentially millions or billions of contracts. And so instead of distributing money all with these restrictions, with these ownership restrictions all over the blockchain, we will be keeping everything here. So as in the non-scalable version. So we will be accepting funds in the master contract, but instead we will be giving people like a bond, right? So they have this promise to get refunded if the campaign is not successful. So yeah, we will be giving them kind of tokens, not really tokens, but kind of tokens that represent their ability to claim funds in the future. Right, so let's call this contract something like bond token, for instance. It needs to have init function, a constructor, and it has to have some information about who actually donated, right? So we need to get our map from addresses to donations and move it here, right? So the Ton blockchain will handle this map for us. We will need to just provide kind of keys and values, so to speak. Well, not really keys, but so here we will be. How do we call it? Yeah, I'm kind of out of great ideas of how to call it. Maybe a sender or backer. Sorry, yeah. So we will be. So contracts, they have their own addresses, and it's not necessarily the address of the backer. It will be for certain, for sure, not the address of the backer. They're all unique, right? So we need to store the backer address here, and we need to store donation here. So donation, I think we used 64-bit integers. Okay, we will need some more contract fields here, but let me add those as we actually understand what is needed, right? So right now, what we need is we need the backer. The donation we will be initializing here to insert self.backer equals backer. and self-donation equals 0. And I'll explain why it's 0 here, right? This is the constructor. Anyone in the world can deploy this contract. So we cannot let people arbitrarily create these bonds, because if a campaign is not successful, just non-backers, random people would be able to get refunds, and we do not want to allow that. So if people deploy this contract, their donation will be 0. And so all the donations will be coming just from us, from crowdfunding contract. This is how we try to do access control here. So only backers would be able to get a bond token. And also there's one more piece of information we need as of now. And since there can be multiple crowdfunding campaigns, meaning we need to somehow connect that this bond token belongs to this particular campaign. And for this, we will be saying something like campaign, which is address. So the bond tokens that we will be distributing will have this campaign address. So like to have this link back to the campaign, it will store the backer and it will store how much they donated. But this donation will be coming only from our contract. And so to this end, let's just switch for a bit to the crowdfunding contract and write this logic here. So how do we donate? Well, let me probably move this up there. And so this part we have not touched yet. We have not rewritten, refactored, so to speak. So when we receive donation, still we need to make sure that this condition holds. It is before the campaign deadline. And then we check that we cannot donate more than once. We won't be doing this exactly like this. And also that will be handled by the token, basically. So here we just need to comment out this logic and implement something like this in the bond token. So we're going to be sending. Okay, we're going to be sending some parameters, a message, right? So it needs to be 2. So here is a question: where do we send it? We need to send it to this contract bond token. So let us create it. Yeah, I'll explain what it means in a moment, state init. So we need to use this init of construction and init of bond token. And for the bond token, we need to put, so how do we initialize it? Oh yeah, I forgot to add one more thing here. So this needs to get campaign. So this is what we do during initialization, right? So during contract deployment, or like object construction, so to speak. So campaign comes from my address here, right? So contracts can query their addresses, right? So this is the address of the master contract. And so the address of the master contract is the unique identifier that identifies a crowdfunding campaign. And then we need to put here who actually is the backer. So, right, the second parameter. So, and the sender is context.sender. And so this bond thing, we can now say, if we know contract's code and contract's initial data, which is, so the code is defined by the contract bond token. It's not ready yet, but still, and these initial data here will be, again, unique for each campaign and each sender. And so we using this information, we can always compute, it's the design of the Ton blockchain that we can always compute the address of the contract which is going to be deployed. So it's not like given by the blockchain post factum, but we can actually compute it before deployment, which is a beautiful thing actually, and we will see later how it can be used here. So first of all, we can contract address of bond of this state in data structure. So it's like code and data of the contract. So we sorry, it should be comma here. Right. So this is 2. Then we need to provide the amount of Ton coins. Here it is 0, and this is important here because we accept all the donations in this master contract, and we do not send it to the bond token contract. We also need to say here body, and now we can send a message to that contract. So we need a receiver, and we cannot use right now something like donate or bond, let's say get bond, because we need to know the amount of money, and we're not sending it here. So when you receive something, some message here, then the Ton coins, the amount of Ton coins from context dot value is not going to be appearing here. It will be a really small amount, basically. So instead of just using strings, we're going to be using messages, and this message we will be calling bond. A promise, you can call it as well. Or fund. And this is going to be message bond, and we need to know the amount. We don't need this. Okay. So when we receive a message bond, we will have access to the amount. Okay, so here we're sending bond, the bond message with the amount, which is equal to what we are getting here. So this is context dot value. And here the body of this needs to be a cell. So we need to call the cell method here. And since this is not deployed, not yet deployed contract, we need to say code, which is bond.code, and data, which is bond.data. You can keep this. Oh no, you cannot probably keep it right now. Trailing commas, I think, are not allowed in Tact 1.2, which is what we're using here. All right, so this will be sending a message that if this contract is not deployed, it will deploy it. using the coded and initial data. And it will also send a message to that contract. And only in this message, we're saying how much money they donated, right? And so in this case, we still need to prevent this cannot donate more than once thing. So we kind of did this thing by deploying a new contract. And so instead of this context.sender key, we have as a key essentially the address of the bond token contract that we're deploying. And we still need to prevent these multiple donations from the same backer, right? And so how do we do this? One of the most simple ways would be to require it here. We require that self donation is 0, right? Otherwise, we can probably just copy it from here, the error message. And then we need to say self donation equals message.amount. Right. Okay. We still need to make sure here that, for instance, if something goes wrong here, that we do not actually freeze the user's money here. So what if this part is unsuccessful, but we already accepted the money, right? What if they don't get the bond here? What if this receiver fails? So in this case, we need to deal with the bounced messages, which is what you get when something goes wrong. And we need also to say the mode here. So this is, for instance, here you're supposed to use something, let's say bounce if action fail, right? And for string messages, actually bounced messages are not, bounced message processing kind of is not available as of now. So this is like homework, but I will be showing it for a different thing. This is homework to process failures in here. So we probably can remove this part. Right, so we accept the donation. Okay, this looks good enough, I would say, to me, or maybe we can refactor it into something else. Or maybe we need, yeah, right. We need to do something about like anyone. So here's an issue, right? So before we didn't have this issue, but here anyone can send this message bond, right? And for instance, if we leave it like this, then I can create a new contract, for instance, or I don't know, some kind of front end, and call this receiver of the bond contract. So like anyone in the world can do that, and which means that if a campaign is unsuccessful, you can create bonds out of thin air and get them cashed, right? So we also need to make sure that the request is coming from the right source, right? So it's the sender is the campaign contract, and otherwise unauthorized. Something like this. And this information we already have, right? And I need to put self here. Okay. All right, so we can accept donations and write it into the blockchain. Now, what else? What else do we need to do? Let me quickly. Okay, we need to claim funds, right? So as before, only the owner can claim the funds. All of these are still the same. Now, what do we do? Still, we have all the funds in our contract. So we need to send this message, and looks like we don't need to change anything here, right? Okay, so this is already good. So what do we do with refunds? So here we can. So first of all, what comes to mind that this receiver needs to be moved out of this contract, right? Because this refund function, it has access to the backer's map. So if you go here, you see this refund. So this is just refactor, so not to duplicate code over here. And it has access to the backer's map, which is not present here. So that means we need to move at least some part of its logic to the bond token, because only the bond token knows something about the donations, right? Only it has this information backer and donation, right? So, all right, but it doesn't actually have this logic. It doesn't have this knowledge of campaign deadline. And one approach would be to just record this and have all of this here. But if you think about this bond token contract does not have any actual money in it, any ton coins. So we still need to do some process, process some here, right? Some stuff here, and then forward the rest to the master contract, to the crowdfunding contract. So still, actually, maybe I was too quick to try to move it. Let me try to move it back, because here we need to do something about this still. Still, this processment should be on this side. And let me yeah, I'll reuse the name here, get refund. So right now, if you are a backer, you donate to the master contract, but then you get a new bond token. And then after that, you need to get refund from it, which will forward the message to the master contract. Right, so how do we do that? Let me think. Well, first of all, you need to ask the master contract, right? So we might need to check some parameters. So two needs to be self.campaign. Right, so then we need to save value here, and value is 0 again. Or, yeah, we can probably actually, yeah, it is still, yeah, value 0. Mode needs to be send. remaining value, I would say, plus send ignore errors. Or actually, no, we're not supposed to. We're not supposed to ignore errors in this case, right? We need to bounce if action fail. We need to send message, and this message would be refund. So the master contract needs to know how much money to refund. And the master contract needs to know who do we issue refund to. And so here we need to say refund to is going to be the backer. So we return back the Don coins to the backer. And the amount would be amount. Sorry. Yeah, amount, right? Amount. Amount would be self.donation. This needs to be a cell. And that's it. Yeah, we don't need any code because that was already deployed. All right, so, but the thing is, if we send this message, get refund, and by the way, what we also need, yeah, we send this message, get refund, we need to protect the master contract from getting multiple refund requests from the same from the same bond token. And so in this case, I guess there can be different approaches to this, but let me add a new piece of state, which we will keep. So is it refunded or not? And here it is not refunded initially, right? And here we will be saying self.refunded equals true, but we cannot actually do it like this and rely on the fact that it will be always successful. For instance, we can, let's say we make a mistake and we send this refund request in the middle of the campaign, right? That would make our contract kind of unusable, right? Because we need to also check that we did not get refund. So like this. Right. So in this case, it is already if this flag is true, it is already refunded, or it's pending refund. All right. So there is some syntactic support, semantic support in Tact. We need to, if this refund message is bounced, then we need to say that we did not get refunded. So if this is unsuccessful, if the refund request is unsuccessful, we will get a bounced message. You can read about bounced messages in the Tact documentation. But basically, yeah, it is unsuccessful. We get this called automatically, and then we say again, we can ask for a refund again. And if it is successful, then this won't be called, and then we will be asking for refunds just once. So this is how we protect against multiple refund requests from the same user, basically. Right. So what else? We need to process this refund. So here I will be using this refund. All right, so what do we do here? So first of all, yes, we need the same logic here. We throw an exception if some funding goals or deadlines are not met, and we need to, in this case, change the refund function. And also we need to do access control here. But let's just change the refund function and talk about access control. Well, basically we're almost done. All right, so we remove this info, used to remove this info in the previous version of the contract for each sender, and here it is taken care of with the refunded equals true over here. Okay, so we can remove this part. And yeah, there is a require saying that only backers can refund. So this still needs to be addressed. So let me put it like this in a comment right here. Yeah, it is basically just we are supposed to just send a message to, but not the sender in this case. We have the message refund. So we recover this information from the message, from the incoming message. So this is 2, and the value is message.amount minus small fee, send remaining value, send ignore errors. Yeah, let's for simplicity leave it like this. And we need to make sure that only backers can get refund and not some random person, because right here, right now, anyone in the world can call this receiver and ask for a refund. And right here, right now, there is no access control mechanism, so like anyone can get a refund by just pinning directly the master contract. So we need to make sure that these refund requests only come from the right source, and the right source would be the bond token. Okay, so how do we do this? So we need to only accept bonds that come from us, right? So from the right type of bond token. So again, this beautiful thing about the Ton blockchain is that everything is kind of predictable here. So we need to say init of bond token, and then it is supposed to be a bond token that was deployed with the address of the master contract, right? And it is supposed to be coming from message 2, right? Because there is a backer. We created bond token for them, and they asked for refund, and then we got that here, right? So we saved the amount they donated in that bond token contract, and now we are recovering this info here. And so this actually guarantees, well, not this, we just didn't finish it. We need to require that the sender is actually bond, it's a contract address. Contract address of bond. And so this provides this access control mechanism. So we know that the sender is an actual bond token with these parameters, and it cannot be it can be kind of faked, but the amount of basically the bond amount would be zero always, because it is hard coded in the initialization logic of bond token, and this part guarantees that it comes from the right business logic, basically. And I think this is it. I hope I did not forget anything. It's again, we didn't have enough time to actually test this, so might have some bugs here. And of course, this is not like production grade smart contract, but more or less that should give you an idea of how to design contracts for the Tom blockchain. So you see all these like access control stuff that comes up, right? You need to introduce some maybe like weird checks. You need to pass messages to and from. You need to recover from failed messages and all that kind of stuff. So I hope this was useful for you. And if we have any questions, let us address those. Yeah, thank you for coming. Thank you for listening. Okay, I'm not sure if Lindvin, can you hear us? I'm sorry, I couldn't address your questions as I went along. Okay, I see some. Okay, now I see some messages. All right. Could you please elaborate where is my profit as a contract developer? For example, I create crowdfunding platform where everybody able to use my contracts to launch crowdfunding. I saw a line with fee. Yeah, I mean, I did not actually address like this profits. That would be a bit too involved. So as a contract developer, no, there's no profit basically. You can add your own custom logic. So, but cannot understand what happens when donation minus sell.fee. Is it the commission to the network or a commission to the contract creator? So basically, we have to pay for storage. So that's why I'm not returning the full donation, because contract can be, campaigns can be quite lengthy, and someone needs to pay for the data to actually store it on the blockchain. So that's why that's minus some fee. Of course, in a production grade contract system, you would need like some custom logic and be more precise about these fees, for instance. Next question is what I need to use for delaying refund, for instance, by 5 days. Yeah, great question. How to delay it by 5 days? Still, you would need some kind of. I would say it should be some kind of off-chain mechanism to do that, because you cannot like have some kind of timer there on the blockchain, on-chain timer. It's not going to work like this. So you might need some, for instance, off-chain system, and then again introduce some kind of deadline for refunding. And so, yeah, it can be done, but you will have to use some off-chain mechanism to actually trigger it again. I also was perplexed by the possibility to update the contract. As any language suffers evolution, would it mean that the old contracts after some time, even these are not updated, will still work? Yeah, I mean, you still have to program those updates, right? So old contracts, especially if they don't have any logic to update their own code, will still work. Yeah, if you pay, if your contract has enough money to pay for the storage. Yeah. Hope that addresses your question. Next question is, can't we restrict the address that can deploy the bond token only with parent crowdfunding contract? I mean, you can, like, nothing prevents you from deploying contracts, right? Like, anyone can deploy it. And this parent just needs to be a parameter, deployment parameter, kind of. Or you mean like, oh yeah, I think I got the question wrong at first. So, or you could use the code of the master contract, right, in there, because you know the address it's going to be deployed, right? But wait, actually no, you cannot know it, right? Because there are lots of parameters here, right? Yeah, that's an interesting question. Actually, I need to probably think about it. Require we use error messages as a plain text. How will they map to error codes later? Oh, as far as I remember, in the implementation, there will be like hashes of those strings involved in those error codes. So error codes in this case can be like really huge, kind of unusual. Instead of using these, you can, for instance, use the throw instruction and specify exact codes there. It's also possible. So here we do this for simplicity. All right. I think there are no more questions. All right. If there are no more questions, then I'd like to thank everyone for participating, for the great questions here, and happy tacting to you.